Hello everybody, welcome into another lesson. So today we are going to review polynomial long division, synthetic division, and then we're going to talk about the remainder and factor theorems. So these are particularly useful for factoring polynomials, and it's going to lead into solving for zeros of polynomials. This is all going to prepare us for when we go to graph polynomial functions. So we're going to do a few examples of polynomial long division, but our main focus will be on the synthetic division. But here you have 2x squared plus 10x plus 12, all that divided by x plus 3. Well, let's go ahead and do this by polynomial long division. So again, in your dividend, put that 2x squared plus your 10x plus your 12 in the dividend. In your divisor, you'll put the x plus 3. And then, of course, now you figure out x times what equals 2x squared. Well, that, of course, would be 2x. And then you'll multiply 2x times x is going to end up being 2x squared. And then 2x times 3, that'd be plus 6x. So then you'll just subtract the row you just got from the dividend. So this would end up giving you 4x plus 12, which now we figure out how many times does x go into 4x. It would go in 4 times. So 2x plus 4 up top in the quotient. So now take 4 times x, that would give you 4x. And then 4 times 3, that's going to end up being plus 12. So subtract the row you just got from the row above it, you get a remainder of 0. So literally your answer should be 2x plus 4. And since there is no remainder, it turns out this is actually a perfect factor. The x plus 3 would be a perfect factor of 2x squared plus 10x plus 12. I'm going to do 2 more of long division, and then we're going to go on to synthetic division. All right. So let's see. We're going to divide 7x to the third plus 3 divided by x plus 2. So let's go ahead now, set up our long division here. So you're going to, of course, put 7x to the third in your dividend. But when doing long division or even synthetic division, you want to account for all the lower powers between the highest power and the constant term. So we don't have an x squared term. So you're actually going to want to write plus 0x squared plus 0x because you don't have an x to the first term, then plus 3. So we have all that now, and then you'll just have your x plus 2 in your divisor. All right, so x goes into 7x squared how many times? It goes in 7x. It goes into 7x cubed how many times? It goes in 7x squared times. Now, if I take 7x squared times x, I'll end up getting 7x cubed. Then I take 7x squared times 2, that gives me plus 14x squared. So this is why you have to account for every power between the highest power and the constant term. Because when you're doing your division, you'll actually end up getting those powers in between. So now subtract this row from the divisor above it. So you'll end up getting negative 14x squared. And then you'll bring down that plus 0x from your dividend. All right, so x goes into negative 14x squared how many times? It goes in negative 14x times. So you'll have 7x squared minus 14x. Okay, now take that negative 14x times x. You'll end up getting negative 14x squared. And then negative 14x times 2, that's minus 28. x minus 28x. Now subtract this row you just got from the row above it, you'll end up getting positive 28x. But then you have to bring down that plus 3 from the dividend. X goes into 28x how many times? It goes in 28 times. So you'll have plus 28 in the quotient. Now take 28 times x. That's going to end up giving you 28x. Then take 28 times 2. That would end up being plus 56. Now subtract this row from the one above it. You'll end up getting negative 53. So you have a remainder of negative 53. So how would you write this in the proper form for the factored version of this polynomial? This would end up being 7x squared minus 14x plus 28. Now that remainder of negative 53, that's going to be the same as minus 53 over x plus 2. Because that remainder is always over the divisor. So when you divide these two polynomials, you are left with 7x squared minus 14x plus 28 minus 53 over x plus 2. And one more with polynomial long division, then we'll go on to synthetic division. Good one. So we're going to take x to the fourth. We're going to divide that by x minus 1 to the third power. So we're going to take x to the fourth, divide that by x minus 1 to the third power. Well, it might help us if we expand that x minus 1 to the third power using the binomial theorem that we covered in Algebra 2. So this will turn into x to the fourth divided by... Alright, so let me actually put a bracket here. So we can use that shortcut we got from Algebra 2 when dealing with the binomial theorem. Take your first term, that x, raise it to the third power, plus... Now you're going to have to take that power of 3, multiply it by your coefficient on the x cubed. Well, 3 times 1 is 3. Divide by the number of term you're currently on, which is the first term. 3 divided by 1 is 3. Then you would take that x, lower that by 1 power, so you'll end up getting x to the second, and then you'll raise that negative 1 a power. In this case, it'd be negative 1 to the first. Plus, now if you take that 2 times 3, you got to take that power of 2 on the x, multiply it by your coefficient of 3. You'll end up getting 6. Divide by the current term you're on, which is the second term. You'll end up also getting 3. So you'll have for the next term 3 times your x lowered 1 more degree, so 3x to the first. Then raise your negative 1 another power, so 3x to the first times negative 1 to the second. And then take your 1, multiply it by that coefficient of 3. 1 times 3 is 3. Then divide by the current term you're on, which is 3. So you'd end up getting a coefficient of 1. Lower your x another degree. 1 times x to the 0 is just 1. And then raise your negative 1 another degree. So this would be plus negative 1 to the third. So in simplified form, this is going to become x to the fourth divided by x to the third minus 3x squared plus 3x minus 1. Now we have something we can actually work with for our polynomial long division. Okay, so let's go ahead and set that up. So the x to the fourth is in the dividend. And we're dividing by a polynomial that has every power lower than x to the fourth, including a constant term. Oh, so that means we have to account for those powers. So this will be plus 0x to the third plus 0x squared plus 0x, and then the constant term we even have to account for, plus 0. You have to account for all those when you're doing any type of division, whether polynomial long division or synthetic division. Okay. Now we're going to make this our divisor. That's going to be divided by x to the third minus 3x squared plus 3x minus 1. So there's your full divisor. Now, how many times does x to the third go into x to the fourth? It goes in x times, right? If I take x times x to the third, what do I get? I'll get x to the fourth. And then if I take x times negative 3x squared, I'll end up getting negative 3x cubed. And then if I take x times 3x, I get plus 3x squared. Then if I take x times negative 1, I'll just end up getting negative x, so minus x. Now just subtract what you just got from the dividend row above it. You would end up getting 3x to the third minus 3x squared plus x. And then I have to bring down that plus 0 from the dividend above. All right, so now how many times does x to the third go into 3x to the third? It just goes in 3 times, right? So this will be plus 3. All right, so now you'll take 3 times x to the third, which would give you, in fact, 3x to the third. Then take 3 times negative 3x squared, so that'd be minus 9x squared. Then take 3 times 3x, so that'd be plus 9x. And then you'll end up getting 3 times negative 1, that's negative 3. So now go ahead and subtract the row you just got from the row above it. You'll end up getting 6x squared minus 8x plus 3. And that's the best you can do. This actually, the whole thing ends up being your remainder. So the proper form is going to be x plus 3 plus that 6x squared minus 8x plus 3 all over that x cubed minus 3x squared plus 3x minus 1, which we know factors into x minus 1 to the third. You can also write the denominator in its factored form. So you end up getting x plus 3 plus the quantity of 6x squared minus 8x plus 3 all over x minus 1 to the third. So that's how long division works. Now let's get into some synthetic division. Okay, so now here's the thing though, with polynomial long division, your divisor could be of any degree. With synthetic division, your divisor can only be linear. That's the downside to synthetic division, but it is quite nice. So let's say we have something like 3x to the third minus 17x squared plus 15x minus 25, all that divided by x minus 5. So you'll have 3x to the third minus 17x squared plus 15x minus 25, all that divided by x minus 5. So when you're setting up synthetic division, you kind of are going to make a table. So in the top part of the table, you're going to list all your coefficients of the dividend. So the x to the third, you have a 3. On the x to the second, you have a negative 17. on the x to the first, you have a 15. And then on your constant term, you have a negative 25. So as long as you're accounting for the highest power, the constant term, and every power in between, you're good. And then that x minus 5. So what are we going to do with that? Well, whenever you divide a polynomial using synthetic division, it's that polynomial divided by x minus k. And by the way, your coefficient on your x to the first term in the divisor should always be 1. If it's not 1, you need to make it 1. But anyway, this is going to be, what you have to do is take that x minus k, in this case x minus 5, set it equal to 0, and you would get x equals k, or x equals 5 in this case. You're going to divide by positive 5. That's what you would do. Now, here's what you're going to do next. You're going to bring down your first term from above, bring down that 3. So that gets brought down by default. Okay. So now you'll take 5 times 3, which is 15. You'll put that below the negative 17. Then you're going to add these two terms. Negative 17 plus 15 is negative 2. Now take 5 times negative 2. You'll end up getting negative 10. So take that negative 10, add that to your 15. You end up getting 5. Now take your 5 times 5. That you'll get 25. Put that below your negative 25. You end up, add the 2, you get 0. So how does the result work? Well, that 3 is the coefficient on the term 1 less than your dividend. So in other words, what this result is, that's the coefficient of 3x squared minus 2x, because it goes in descending order, plus 5. That very last number on the bottom right is your remainder. You don't have a remainder in this case, so your result is going to end up being 3x squared minus 2x plus 5. And in some ways, I think synthetic division is actually nicer to use. It has its drawbacks, but overall I think it's better than polynomial long division. Alright, let's say we had something like 5x to the third plus 6x plus 8 divided by x plus 2. Alright, so you have 5x to the third plus 6x plus 8 divided by x plus 2. We're going to use synthetic division again. So set up your table. Now you have to take the coefficient of your dividend. You put that here, every coefficient. On the x to the third, you have a 5. Notice you don't have an x squared. You still have to account for x squared like you did in polynomial long division, so you'll put a 0 for your x squared. Your x to the first has a 6, and then your constant term is 8. So you should see 5, 0, 6, and 8 for your dividend. Now your divisor, take that x plus 2, set it equal to 0, you would get x equals negative 2. So we're dividing all this by negative 2. Now we can go ahead and proceed. Bring down that 5 from above, put that below the table. Now take negative 2 times 5. That's going to give you negative 10. So then take your 0 plus negative 10, you get negative 10. Take negative 2 times negative 10, that's going to give you 20, so put that below your 6. So 6 plus 20 is 26. Alright, negative 2 times 26, that's going to be negative 52. Put that below your 8. 8 minus 52 is negative 44. So that negative 44 is your remainder. So that means this is going to break down into again, that first number is the coefficient on the x term that's one less degree than in your divisor. So this would be 5x to the second minus 10x to the first plus 26. So you see how you end up getting an x to the second term anyway. This is why you have to account for every single power when you're doing the work. Now that minus 44, that's your remainder. That's always your remainder. This number to the right is always your remainder. So this would end up being minus 44 all over that divisor of x plus 2. Because the remainder is always over the divisor. So this ends up becoming 5x to the second minus 10x plus 26 minus 44 over x plus 2. All right. Let's do one more basic synthetic division, then we're going to talk about the remainder and factor theorems. All right, so we have 3x to the third minus 4x squared plus 5, all that divided by x minus 3/2. Yes, you actually can have divisors that are fractions or decimals. It happens all the time, actually. So 3x to the third minus 4x squared plus 5, all that divided by x minus 3/2. So let's go ahead and set up our table for synthetic division. Now the polynomial that you're dividing itself is your dividend. So take every coefficient. Your x to the third coefficient has a 3, so you'll put a 3 here. Your x to the second has a coefficient of -4, so put a -4. You don't have an x to the first, so that has a default coefficient of 0. Then you have a constant term of 5. So you should see 3, -4, 0, and 5. Now, for your divisor, take that x minus 3/2, set it equal to 0, you get x equals 3/2. So you're dividing all this by 3/2. Now we're ready to proceed. So go ahead and bring down that 3 from above. Now take 3/2 times 3. What's that going to be? That's going to end up being 9/2. All right. Now what's -4 plus 9/2? Well, that's the same as -8/2 plus 9/2. That would end up being 1/2. All right, now go ahead, take 3/2 times 1/2. You end up getting 3/4. So what's 0 plus 3/4? That's 3/4, of course. Now take 3/2 times 3/4. You'll end up getting 9/8. So take 5 plus 9/8. All right, so what is 5 plus 9/8? That's the same as 48 plus 9/8. You would end up getting a remainder of 49/8. So how you're going to write the result is then you'll end up getting, for your quotient, it'll be 3x squared plus 1/2 x plus 3/4 plus that remainder of 49/8, so plus 49/8 all over your divisor of that x minus 3/2. That's exactly how you would write the result. You'll end up getting 3x squared plus 1/2 x plus 3/4 plus 49/8 over x minus 3/2. All right. So let's go ahead and talk about the factor theorem. So, or the remainder theorem, excuse me. this may seem like a review from Algebra 2 when we covered synthetic division, and really, truly it is, but it's very necessary. For any polynomial divided by x minus k, then the remainder equals f of k. So that remainder, so in other words, let me see how I want to word this. I know what the theorem is, I just want to word it right. Yep, r equals f of k. So basically this is talking about something called synthetic substitution. That kind of throws us back more towards the beginning of Algebra 2. So if you, for example, let's say I'm given f of x equals 2x to the third minus 7x plus 3. Well, first and foremost, they would like for me to evaluate f of 1. First, we're going to do this by direct substitution, which direct substitution is I just put in 1 for x. So that would be 2 times 1 to the third minus 7 times 1 plus 3, which would end up giving me 2 minus 7 plus 3, which would end up giving me negative 2. I get that via direct substitution. Well, this remainder theorem states that I can use synthetic division. I can divide the polynomial itself by 1, and then that my remainder is equal to that f of 1. So let's show you now synthetic substitution. So let's do f of 1 using synthetic substitution, okay? So I'm going to take my coefficients of my polynomial. So that's going to be the 2x to the third. So you'll just have the 2 on the x to the third. You don't have a 0, you don't have an x squared term, so the coefficient on that's 0. You have an x to the first term, the coefficient's negative 7. And then my constant term is 3. Now to find f of 1, I'm just going to divide all this by 1. So let's go ahead now and do the synthetic division. So bring down your 2. 1 times 2 is 2. Add that to 0. 0 plus 2 is 2. 1 times 2 is 2. So negative 7 plus 2 is negative 5. All right, 1 times negative 5 is going to end up being negative 5. 3 minus 5 is negative 2. So that's my remainder, which tells me via synthetic substitution that the remainder, which means negative 2, equals my f of 1. And we got the exact same thing with direct substitution. Sometimes synthetic substitution actually is better because then you don't have to worry about powers and making mistakes expanding everything to power. It does the exact same thing as direct substitution, only sometimes it's actually easier. That's all this remainder theorem is stating. That whatever my remainder is, for whatever factor I use, that's the same thing as taking f of 1 in this case, or in general f of k. That's the value that you would get. So let's keep with that polynomial. Let's do f of negative 2. So let's take f of negative 2. So this time set up your synthetic division again. So coefficient on x to the third is 2. I don't have an x to the squared term, so that's a 0 coefficient. X to the first is -7, and my constant term is 3. We're dividing by -2, since we're trying to find f of -2. Now go ahead, bring down your 2 from above. Alright, so take -2 times 2, you end up getting -4. 0 minus 4 is in fact -4. Now -2 times -4 is +8. So -7 plus 8 is +1. -2 times 1 is going to be -2. Then 3 minus 2 is 1. So there's my answer. That means f of -2 equals 1. It's a lot quicker than trying to do everything to powers. All right. Let's do another one here. Another polynomial entirely. F of x equals x to the third minus 5x squared minus 7x plus 4. Let's take f of 2 this time. So we have a brand new polynomial and we're going to find f of 2. So that means I'm going to take this polynomial, put that as my dividend. So the coefficient on x to the third is 1. Actually, I'd like to save that green for a minute. I would like to save that. Let's make my table better here in black. Okay. Coefficient on x to the third is 1. Coefficient on x squared is -5. Coefficient on x to the first is -7. Then my constant term is +4. I'm going to divide all that by that. You have the f of 2, so you're dividing everything by 2. Alright, so now I'm going to bring down that 1 from above, and then 2 times 1 is 2. Put that below the -5. -5 plus 2 is -3. 2 times -3 is -6, so -7 plus -6, that's -13. And then 2 times -13 is -26. 4 minus 26, that's -22. So that remainder gives me my answer for f of 2. So that means in this case that f of 2 is going to equal -22. Let's do another polynomial. All right. F of x equals, we're going to take it up a degree, 4x to the fourth minus 16x to the third plus 7x squared plus 20. So f of x equals 4x to the fourth minus 16x to the third plus 7x squared plus 20. And this time, let's find f of -5. And for this one, I think you'll be glad we're using synthetic substitution instead. So go ahead, let's do our synthetic division table here. So our dividend, coefficient on x to the fourth is 4. Coefficient on x to the third is -16. Coefficient on x to the second is 7. We don't have an x to the first term, so that's going to be a 0 coefficient. Then our constant term is +20. So it's just writing everything out in descending order. And since we're evaluating f of -5, we're going to divide all this by -5. So let's go ahead now, bring down that 4 from above. So negative 5 times 4 is negative 20. So negative 16 minus 20 is going to end up being negative 36. Now we got to take negative 36 times negative 5. That would give you positive 180. 7 plus 180 is 187. Now take negative 5 times 187. You end up getting negative 935. So add that to 0. You end up getting negative 935. And then take negative 935 times negative 5. You end up getting positive 4,675. So now add that to 20, you get 4,695. So that remainder is your answer, which means that f of negative 5 is going to equal 4,695. And yes, we should all be very glad that we didn't do direct substitution in this case. All right, one more with the remainder theorem, then we'll do a couple with the factor theorem. All right. F of x equals 2x to the 6th plus 3x to the 4th minus x squared plus 3. And we are seeking to find f of 3. So we want to find f of 3 for 2x to the 6th plus 3x to the 4th minus x squared plus 3. Another one where we should be glad we're using synthetic substitution instead. So your dividend would be this polynomial, so the coefficient on x to the 6th is 2. We don't have an x to the 5th term, so that coefficient is going to be 0. We have an x to the 4th term, that's going to end up being 3. We have no x to the 3rd term, so there's another 0. The coefficient on x squared is negative 1. We have no x to the 1st term, so there's another 0. And then our constant term is 3. Yes, what a mess, huh? Let's divide all this by 3. So now bring down that 2 from above. Okay, go ahead, take 3 times 2. That gives you 6. 0 plus 6 is 6. All right, 3 times 6 is 18. 3 plus 18 is 21. 3 times 21 is 63. 0 plus 63 is 63. 3 times 63 is going to be 189. Negative 1 plus 189, that's 188. Now take 3 times 188. You end up getting 564. So add that 564 to 0, you get 564. Now take 3 times 564. You end up getting 1,692. Add that to 3, you end up getting 1,695. And that remainder is your answer. So in this case, that means f of 3 equals 1,695. That's exactly what you would get. And again, no exponents to deal with. It just turns it into simple multiplication and addition. That's what's nice about the remainder theorem. Now the next part is called the factor theorem, and it kind of piggybacks off the remainder theorem a little bit. let's bring up the factor theorem. So for any polynomial divided by an x minus k, if the remainder equals 0, if you have a 0 remainder, then x minus k is a factor. So if you're doing, this applies to synthetic division. For any polynomial divided by the x minus k, if r equals 0, so if your remainder equals 0 and only 0, then that x minus k is a factor of the polynomial. Now, if you get anything, and I mean anything at all other than 0, it's not a factor. The remainder has to be 0. So let's do that here. So we have, let's see, f of x equals x cubed minus 7x plus 6 for a value of x equals 2. So what does that mean? That means we're going to take this polynomial and divide by 2. So let's go ahead, set up your synthetic division. The coefficient on x to the third is 1. You don't have an x squared, so that'll be 0 for that coefficient. Your x to the first is negative 7. Your constant term is 6. You're dividing this by 2. So in other words, you're taking f of 2. Now let's go ahead and bring down the 1 from above. Okay, so 2 times 1, that's going to end up being 2. Now 0 plus 2 is 2. 2 times 2 is 4. Negative 7 plus 4 is negative 3. 2 times negative 3 is negative 6. And then 6 minus 6 is 0. Well, you have a remainder of 0. So that means that x minus 2 is a factor. And you can also use the remainder theorem to say in this case that f of 2 equals 0. That's how they piggyback off of each other. Then f of 2 equals 0 by the remainder theorem. So now we need to write this f of x in its factored form. So f of x, since we know x minus 2 is a factor, that's going to equal x minus 2 times the quantity of that x to the second plus 2x minus 3. Which really, we probably could factor this further, but it looks like it will factor further, but we're not going to do that today. I just want to show how it works in its factored form between the factored and the quotient. And if you had a remainder, then you would put your remainder off to the side of that. All right, f of x equals x to the third minus 28x minus 48. They're going to give you that x equals negative 4. So let's divide this polynomial by negative 4. So the coefficient on x to the third is 1. We don't have an x squared, so that's a 0 coefficient. X to the first has a coefficient of negative 28. Your constant term is negative 48. So now we're going to go ahead and divide all this by negative 4. So go ahead, bring down your 1 from above. So now negative 4 times 1 is negative 4. 0 plus negative 4 is negative 4. Negative 4 times negative 4 is positive 16. Negative 28 plus 16 is negative 12. Now negative 4 times negative 12 is positive 48. Negative 48 plus 48 is 0. So we actually have another remainder of 0. So by the remainder theorem, that means in this case that f of negative 4 equals 0. And then by the factor theorem, we can write this as f of x equals that factor of x plus 4. Since you have x equals negative 4, that means you're going to have x plus 4 as the factor, times that x squared minus 4x minus 12 for your f of x. I got 2 more, then we're done with the lesson. Yeah, these will get a little bit good here too. All right, so let's say f of x equals 2x to the third minus 15x squared plus 27x minus 10. They're giving us an x value of 1/2. X equals 1/2, excuse me. So we have x equals 1/2. So we're going to take this entire polynomial, divide it by 1/2. And by the factor theorem, we should be able to prove that x minus 1/2 is a factor of this polynomial, because you should get a remainder of 0. So coefficient on x to the third is 2. Coefficient on x squared is negative 15. Coefficient on x to the first is 27. Constant term is negative 10. Now divide everything by 1/2. We're ready to proceed. So go ahead, bring down your 2. So what's half times 2? That's 1. Negative 15 plus 1 is negative 14. Half times negative 14 is negative 7. 27 plus negative 7 is positive 20. All right, so half times 20 is 10. Negative 10 plus 10 is 0. So we have a remainder of 0, which means by the remainder theorem that f of 1/2 equals 0. By the factor theorem, that 0 remainder means that x minus 1/2 is a factor of the polynomial. So this would factor into f of x equals x minus 1/2 times 2x squared minus 14x plus 20. And again, yes, we could factor these further, but we'll do that in the next lesson. Today, I just want you to see how the factored form works with the quotient to express the original polynomial. So it would be the factor times the quotient would give you the entire polynomial. I got one more. All right. F of x equals, wow, big one, 48x to the third minus 80x squared plus 41x minus 6. And this looks pretty hideous, I'm not going to lie. Your value of x is going to be 2/3. So now they really pulled the rug out from under us. So we got to take f of x equals that 48x to the third minus 80x squared plus 41x minus 6. We have to divide this polynomial by x equals 2/3 and come up with a factor for this. So let's go ahead and start the synthetic division process. So coefficient on x to the third is 48. Coefficient on x squared is negative 80. Coefficient on x to the first is positive 41. Constant term is negative 6. All right, all this divided by that 2/3. So go ahead now, bring down that 48. So then let's figure out what 2/3 of 48 is. Well, that's going to end up being 32. So negative 80 plus 32, that should end up being negative 48. And then 2/3 of negative 48 would be negative 32. All right, so what's 41 minus 32? That's 9. So then what's 2/3 of 9? Well, you're going to end up having 6. Negative 6 plus 6 is 0. So there's your remainder of 0, which means that x minus 2/3 is a factor of this polynomial, and by the remainder theorem that f of 2/3 equals 0. So let's express this polynomial in its factored form. That's going to be the quantity of x minus that 2/3 times your quotient, which would end up being 48x squared minus 48x plus 9. That would be your polynomial in its factored form. F of x equals the quantity of x minus 2/3 times 48x squared minus 48x plus 9. So that's it for this lesson. Next lesson, we're going to talk about finding rational zeros. So being able to solve for the real zeros of polynomial functions. We're going to talk about Descartes' rule of signs also, which that tells you how many positive and negative real zeros you can expect for a polynomial function, which is all going to come into play when we get into graphing these functions. So I hope everyone has a great day. Take care.